So we continue with identities with 7.4, proving trigonometric identities. So the basic trigonometric identities, we already discussed it before. The most famous one is cos square x plus sin square x equals 1. Yeah, identity. True. So when we are proving, we separate left side from right side. We never move any terms from right to left, from left to right. Okay? So make sure you write left side and right side separately. And again, don't move any terms from left to right or right to left. Then, actually, we can look at these commonly used techniques first and then go back to this question. Okay? So what are the commonly used techniques when proving identities? Zoom. I wrote exactly the same things. I didn't prove it yet. So I just separated. So you use this equal sign. Okay, and you separate left side from right side. And then we are going to now prove. But before we do that, let's look at commonly used techniques. So it says take one side and change it gradually until it becomes the other side. Usually we work with the most complicated side. Okay, you want to start from the most complicated side. In some cases, it is faster to work with each side separately. Change both until they are the same. So sometimes you can only work with one side and get the other side, or sometimes you can work both sides and where you get exactly the same thing, same expression on the left and on the right, then you can stop. So to prove that a given trigonometric equation is an identity, one may perform the following steps: simplify the more complicated side, rewrite all expressions in terms of sine and cosine, apply the Pythagorean identities where possible. So this is the Pythagorean identity, right? Cos square plus sine square x equals 1. And you may use common denominator, factoring, expand and simplify as needed. Okay, so those are some of the commonly used techniques. Actually, I'm going to add one more to it, and I'm going to say multiply by conjugate. Multiply by conjugate to create difference of squares. To create difference of squares. That's also a commonly used technique. For example, you have 1 plus cos theta. You can multiply it by the conjugate to get 1 minus, you multiply 1 plus cos theta by 1 minus cos theta, then you get 1 minus cos square theta, right? So 1 minus cos square theta, let's say, to create, okay, such as. Then see, you can replace this by sine square theta, okay, or to create 1 minus sine square theta, so that you can get, we replace it by cos square theta, okay. Having said that, we looked at commonly used techniques. What should we do here? Write everything in terms of sine and cosine. That's one method, right? So we can replace tangent square x by sine square x over cos square x, and then have a common denominator. So you get sine square x plus cos square x over cos square x. Now we can use this identity, Pythagorean identity, cos squared x plus sine squared x is 1. So 1 over cos squared x. And this is equal to secant squared x. Okay. Or you can work with the right side and then say this is 1 over cos squared x. Now we have the same thing on the left, on the right. Then conclude your proof saying that left side equals right side. With these questions, when we say it is prove, right? Then we give you an equation and then we say prove. We are not trying to get you, okay? If it says that prove, it is true. So at the end, you should not be getting left side is not equal to right side. If you are not getting left side equals to right side, means you are making a mistake. Okay? So if you say prove, yes, it is something provable. It is true, okay? It will say prove. But don't mix it up with the previous questions, right? These are not equations. This is not proving. This is simplifying, writing everything in terms of sine and cosine and simplifying. But the other ones are gonna be prove, usually. Okay, let's look at example 2. So it says prove 1 plus tangent theta over 1 plus cotangent theta equals tangent theta. So first step, left side, separate left side and right side. Right side is tangent theta. Okay, so now right side looks pretty simple, right? Maybe we should start from more complicated side, which is the left. So we can replace tangent theta by sine theta over cos theta and cotangent by cosine over sine, and then try to simplify it from there. So 1 plus sine theta over cos theta, 1 plus cos theta over sine theta. Okay, now have a common denominator for numerator. So we get cos theta plus sine theta over cos theta. And here we have sine theta plus cos theta over sine theta. Now convert division into multiplication. Cos theta plus sine theta over cos theta times sine theta over sine theta plus cos theta. Now cos theta plus sine theta is same as sine theta plus cos theta. So these can be gone. So you end up with sine theta over cos theta, which is tangent theta. So now left side equals right side. Okay, next one. Example 3, prove tangent theta plus cotangent theta equals secant theta times cosecant theta. So we can replace everything and write them in terms of sine and cosine. Okay, but of course we separate left side from right side. So left side tangent theta plus cotangent theta. Right side secant theta times cosecant theta. Okay, so left side. we have tangent theta, replace it with sine theta over cos theta, and cotangent cos theta over sine theta. Have a common denominator, sine square theta plus cos square theta over cos theta sine theta. Now sine square theta plus cos square theta equals 1 over cos theta sine theta. Okay, so right side, so looks like we need to work with both sides in this case. Right side secant is 1 over cos theta, and cosecant is 1 over sine theta. So this gives you 1 over cos theta sine theta. So now left side equals right side. Yep, this is proved. This one is a little bit more challenging. Okay, example 4. I'm gonna show you two methods for this, and then always, most of the time there is more than one way of proving it. Okay, so you may approach from different. You may use different methods to approach to the problem. So I'm gonna show you, for example, for this one, two possible methods. Okay, so first let's separate left side from right side. And then right side is this. So let's work with this here. So right side 1 minus 2 sine square theta cos square theta. So both sides actually look equally complicated, kind of. So I'm gonna start with the first method from left side. Okay. So how about if I write sine to the power of 4 theta as sine square theta to the power of 2? So sine square theta to the power of 2. Now using Pythagorean identity, we can replace sine square theta with 1 minus cos square theta. Now you can expand this, okay, 1 minus cos square theta squared. So square of 1. Multiply first and second, multiply by 2. So you get negative 2 cos square theta plus square of cos square theta gives you cos to the power of 4 theta. Okay, so far we have 1 minus 2 cos square theta plus 2 cos to the power of 4 theta. It is still not the same, right, with the right, but looks like, if we are getting closer, because 1 is 1 here, right? So you see 1 here on the right, and we have 1 there. So if we can make these two terms look like that, that would be great. So I'm gonna leave the 1 out, and I'm gonna factor 2 cos square theta from these two terms only. Okay, only from these two terms. So negative 2 cos square theta. So I'm again factoring it from these two terms only. So what do I get? 1 minus cos square theta. Well, 1 minus cos square is sine square theta. So you get, now you have exactly the same thing as the right side. Okay? Then left side equals right side. So this is method 1. Okay, with the method 2, how about this time? So of course we are gonna separate left side and right side. So right side, 1 minus 2 sine square theta cos square theta. So this time, instead of from left side, I will start from right side. Okay, so what we can do, either take sine square or cos square and replace it with 1 minus cos square or 1 minus sine square. So let's do that. So right side, so 1 minus 2, instead of sine square, let's say, we can write 1 minus cos square theta. So now let's expand this. So 1 minus 2 cos square theta times 1 minus 2 cos square theta minus 2 cos square theta times negative cos square theta plus 2 cos to the power of 4 theta. So we are close to the left side, right? But not yet. So, but at least we were able to get cos to the power of 4 theta. Okay, if you compare with the left side. But this one I have one of them. Okay, and this here I have 2 of them. So what I'm gonna do, I'm going to separate those and say, how about if I write it as cos to the power of 4 theta plus cos to the power of 4 theta. Oh, there's a plus sign here, guys. Okay, so now can you see what is going on here with these three terms? Huh? It's a perfect square trinomial. So actually that is 1 minus cos square theta squared. So now you know that 1 minus cos square theta is sine square theta. So this gives you sine to the power of 4 theta plus cos to the power of 4 theta. So left side equals right side. I'm pretty sure there is many more methods to prove exactly the same thing. I just showed 2 of them, but probably there is many more. Actually, I'm gonna ask you to work on the other 2. I'm just gonna show the answer sheet for the purpose of the video. Okay, so at least at the end, whoever is watching, stop their videos, do the work, and then look at their answers from here. Okay, so the last one, the example 6, a little bit of different. You have to use the conjugate. Okay, multiply by the conjugate to get the right side, or you can start from the right side, but again you have to multiply it by the conjugate. Okay, I think it can be seen.